Okay, suitability assessment, paper one mechanics, question one, identifying scalars and vectors. So what we've got here, we start off A, power is a scalar, so that's right. Work done here, this is energy transferred, so energy is a scalar as well, so A is incorrect. Velocity is a vector, and power is a scalar, so these two are the wrong way around. Weight is a vector and velocity is also a vector. They both have direction, so that's not right. And the last one, work done, energy, that's a scalar. Weight has direction downwards, that's a vector, so the answer is 1. Question 2, calculating acceleration, that's final velocity, initial velocity over time. So final velocity is 30 meters per second, starts off at rest minus initial velocity divided by the time taken 7.5, an answer of 4 meters per second squared. Question 3, the unit for power is the watt. Okay, so power we know is energy divided by time. So standard units. So if you forgot what energy was in standard units, energy, remember, is work done, which is force times distance. And if you forgot what the standard unit for force was, then force is mass times acceleration. So here we've got mass times acceleration times distance divided by time. That's if you forgot what energy was in standard units or force was in standard units. So mass we know is kilograms, acceleration we know is meters per second squared, and distance we know is meters, time we know it's seconds. So I replaced all of them in their correct place, and seconds at the bottom of the fraction, so therefore bring it up, that becomes s to the minus 1. So it's kilograms, they've got meters times by meters, which is meters squared. Seconds to the minus 2 times by second to the minus 1, that's second to the minus 3, so that there is power. Here, that there is force, kilograms meters per second squared. That there is work done, so energy. This not sure. That's not part of it. And this is power. So here, if you selected A or B, you selected force or work done, and if you selected D, that was the right answer. Question 4. Acceleration at 3 seconds. So this is a velocity time graph. 3 seconds go up, a horizontal line. Remember the gradient of this graph, velocity time, gives you acceleration. So if the gradient here is 0, therefore the acceleration is 0. Okay. Question 5, you got a displacement time graph, and we want to work out the velocity of the runner at 5 seconds. So 5 seconds go up to here, it's a straight line. Okay, so on a displacement time graph, a straight line corresponds to constant velocity. Okay, so displacement over time, that's constant velocity here. Unfortunately, we can't just pick a value and then do the displacement over the time, because that line does not cut across to 0 if you extrapolate it back. So if you just picked the displacement at 40 and divided it by 5, that's the incorrect technique. It's the gradient of this graph that gives us the velocity. And 40 divided by 5, that's 8. And it will just so happen to have 8 there, because that sometimes they do that with the question, they deliberately put the incorrect calculation in. What we do is a gradient. So if we look at the gradient, it says a rise over the run. I could pick any part of the straight line. I can draw a triangle at any point. So what I've done, drawn the a triangle where I found is appropriate. You would have had a different one. So then here I've got 46 as my rise, 3.9 as my run. You might have something different. roughly, and it says approximately, doesn't in the question, so it's roughly around about 12 meters per second as I do the rise over the run. And that there is my velocity. Remember, it's the gradient of a displacement time graph, not picking any value off the graph and then dividing that by displacement over time. Question 6. This is looking at the difference between vectors and scalars. So if you read that there, if I replace the word mass with weight, that entire sentence makes sense. So a car has a weight of 10,000 newtons acting vertically downwards. Weight acts vertically downwards. Mass is a scalar, so has no directional property. Okay, so when it says vertically downwards, that's the weight. So that's why I've written mass has no direction, it's a scalar, or you could have written weight acts vertically downwards, it's a vector, so mass is inappropriate. Next one, the velocity of light from the sun is 3 times 10 to the 8 meters per second. That velocity is directional, so speed of light is a fixed value regardless of direction. So the appropriate word to use here is speed. So the speed of light from the sun is 3 times 10 to the 8 meters per second. Okay, so it does not depend on direction. Here you read the car slows down with an acceleration of 2.5 meters per second squared. So you're looking at slowing down. So the acceleration will be negative against the direction of motion. So the car slows down, therefore the acceleration should be negative. Or you could have said, if you left the acceleration as 2.5, you could have said the car speeds up. So it's replacing the word slowed down, the car speeds up, therefore has a positive acceleration. So you could have said that should be replaced by speeds up, leaving that as a positive, or changing that into a negative because it's deceleration. Question 7 here. This is where many will make mistakes because we are looking at what is average speed. Average speed, basics, what is it? It's the total distance divided by the time taken. Okay, so it says explain why the speed calculated is an average speed over the 0.5 seconds. So we know that the car moving from one in, uh, interval point to another interval point could be changing its speed. So the average speed is calculated by taking the total distance divided by the total time. Okay, so we know that the time taken is over a 0.5 second interval. So we know that the car is going to move from, let's say, here to here. So we'll know the distance traveled. We'll know the time it took will be 0.5 seconds for that distance. So we would not know what the speed will be at each individual point because we've looked at the distance after, the distance before, i.e. the total distance traveled divided by the time taken. So because we've done that, we've got an average speed, and the average speed indicates that the car could be moving at a range of different speeds from one point to the next. So increasing speed or even decreasing speed. So these were required total distance divided by time. So an indication of how you would calculate average speed. As soon as you would have done that, you would have written down the formula. Don't just write distance traveled. Remember, average speed is the total distance traveled, and uh, the word average indicates that the speed is changing. Right, next. So draw lines on your pictures as much as possible. So those two red lines here indicate the start position at t equals 0, end position at t equals 0.5 seconds. We know that the distance traveled was from here to here. Each interval is 1.52 meters. We've got an approximation to make here. So 1, 2, 3, 4 intervals. A little bit more, there's the approximation, about zero 0.2, I would say. So 4.2 intervals, that's 1.52 meters each. And the car took to go from here to here in 0.5 seconds, because that's the snapshot at the beginning, that's the snapshot after 0.5 seconds. So what we could do is you could work out the average speed. So here the distance traveled is 4.2 squares, and that would have been 1.52 meters times by 4.2, and that would have given 6.384 meters as the distance traveled. That took 0.5 seconds. So speed equals average speed equals distance over time, and what we've got is 12.77 meters per second. And if the question is, the speed limit is 50 kilometers per hour, and has the car exceeded that speed? 50 kilometers per hour, that is not meters per second. So I need to change. I've written meters over seconds as meters per second because of the next thing that I'm going to do. So to go from meters to kilometers, I divide by 1,000. So I put divide by 1,000 here and change. So the factor I need to divide this value by is by 1,000, and to change the unit from meters to kilometers. Okay, so that factor of divide by 1,000 comes next to the kilometers. And to go from seconds to hours is divide by 3,600, or 60 times 60. So that is at the bottom of the fraction, divide by 3,600 hours. And these are the factors I need to include to change from meters per second to kilometers an hour. So essentially that means 12.77 divided by 1,000, and because that divided by 3,600 is at the bottom of the fraction, that becomes times by 3,600, and you end up with a speed of 45.96 kilometers per hour, which is less than 50 kilometers per hour, therefore not exceeding the speed of light. So the position of the camera may result in an error in the calculated speed. Suggest why. Now the camera is generally at a position which is higher than the actual car. So if this is the camera, this is the car's position, and there is the car's position later. If this is the let's say the road, okay, and if the camera is looking from this position here, this is what you'll see on the road. That's the marking that you'll see on the road from there. And if you're looking on the same again, it will see the marking further up. Okay, so the car's actual position is here. The marking that it's over is directly underneath. However, the angle of the camera will see the marking here, the further up, and then the marking even further away when you're looking at the car further along the road. Okay, so there is a difference in the distances that the camera picks up. That's what we call parallax error. Due to the angle of the camera to the car and the road markings produce an incorrect distance reading, therefore speed has an error.